Alright, we're going to take a look at evaluating logarithmic functions. It says to find the indicated value of the logarithmic functions without a calculator. I guess that should be values of the functions, right? So we'll put that there, fix that, use a calculator to check. So we'll take a look at that checking in a minute as well. Okay, so what we're going to do is we're going to take a look at just what the meaning of a logarithm is, and this really means this. Number one means this. It says, okay, what is the exponent to which we must raise the base 5 to obtain a value of 25? So here's how we could write it. We could write it in exponential form. Here's what it's saying. What is the value to which we must raise the base 5 to obtain a value of 25? Okay, so this is me writing in an exponential form. Exponential form. Now what I've done is I've kind of, before I move too much further, I actually think of these little expressions as an equation. I create an equation by setting it equal to y. I set it equal to y. I say, hey, let that thing equal the value y. I don't know what it is, but let it equal y, and then we're going to solve for y. Well, if you've looked at my video of 4.1f, I believe it is, then we do know how to continue with this to get the value of y. So if I could get 25 to be written as 5 to some power, then this is actually a property of logarithms and exponents, that property of logarithms, which is the one-to-one property, and so that says, hey, then this y must be equal to 2. Right? If 5s are bases that match, then shouldn't those exponents be equal as well? And yes, indeed they are. So the value of this whole thing is 2. So we set it equal to y, we find out what y is. Let's try another one. I'm going to make this into an equation set equal to y. You can make it equal to any variable, but just set equal to a variable. Now, let's rewrite it in exponential form. Okay, 3 to the y power is equal to 1 over 81. Now, my first goal is to see if I could get the right-hand side to be rewritten as 3 to some power, right? 3 as a base. So let's first rewrite the 81 on the bottom in the denominator as 3 to some power. Well, that would be a 4. So we have still 3 to the y is equal to that. Now I'm going to copy that left side again. I'm going to rewrite this part so that the 3 is a base, and a numerator, not a denominator. Well, the only way to move that to the numerator is to give it a negative 4. So now I can conclude that y is negative 4. There's my answer. Okay, we're going to check these on the calculator in a second. Okay, let's do the same thing to this one. Set it equal to a variable. Now rewrite it in exponential form. The log base 1/7 of 49 is saying, hey, what power must I raise? To what power must I raise 1/7 so that it will equal a 49? All right, well, we're going to actually rewrite both sides this time. I'm going to try to get both of the sides to be expressed as 7 to some power. Well, that's easy. 7 to the second power on the right side. How about the left side? Well, let me keep the y there, and I could rewrite 1/7, as 7 to the negative 1. Right? That's the same thing. Let me highlight that for you. This right here is the very same thing as that. Okay, so I have 7 to the second power. Now I have a power raised to a power, so I'm going to multiply those to get rid of the parentheses. So I have negative 1y. Now the one-to-one property says this. I don't think I mentioned the one-to-one property in the 4.1f video, but I'm mentioning it here. If I have the bases matching in an equation, bases matching, then I'm allowed to take the exponents and match them, right? That means they're equal. That means they have to be equal. So now I'm going to solve for y, and I get negative 2. All right, let's take a look at the calculator. How could we check this to make sure it's right? On this first one, I'm actually going to have to rewrite it. So I'm going to take this right here, because my calculator won't evaluate any base except for a 10 and the letter E, meaning It's actually a constant. It's an irrational number, kind of like pi. It's the letter E, and you've seen it probably on your calculator. But the only way I can evaluate this on the calculator is to change the base. So we're going to change the base. Here's how we do that. I'm going to go ahead and change the base to 10. Now I don't have to write the 10, but I want to write it just so you know that I'm changing the base to 10. The way I do that is I leave this argument up there. So I'm changing the base to 10. That means the log base 10 has to be on the bottom. So I put the 25 at the top, and I put the 5 now is no longer the base. I make it the argument. Now let's put this in the calculator. In the calculator, we're not going to see the base 10. It's just going to look like this. All right, log 25 over log 5. And this is called a common log when a base is 10. The base is not 5 any longer. Here we go. Log 25 over log 5. Here we go. Here it is. Here's log 25. All right, now I'm going to close up the parentheses. I'm going to hit enter. Divided by log 5, 2. There it is. That's what we got. We got that the answer is 2. That's what the calculator got. Okay? Let's take a look at the next one. Again, if I want to put this in the calculator, I'm going to have to use the change of base formula, which says I can change that to log of that, which is it's implying that there's a log a base 10, and then log of that. So log of 1/81st over log of 3. Let's take a look. Clear. Log of 1/81st, enter, divided by log of 3. Close parentheses, enter. -4. There it is. Yay! That's what we got, -4. And the last one, we'll wrap it up with this one. Okay, we said, let's see, we're going to make this, create the change of base here. So we have a log. I'm going to change the base to 10, which means that it's going to be log base 10 of 49 over log base 10 1/7. Whoops, 1/7, Miss Savelle. Well, there we go. Okay, and here we go. Log 49, clear. I have log 49, enter, divided by log, now we're going to go 1 divided by 7. And look at there, -2. That's what we got, -2. All right, hope this was helpful. Thanks for watching.